Okay, students, next we will go through some of the concepts in the topic, that is what now? Molecularity of the reaction. Molecularity of the reaction is very, very important one only. In the chemical kinetics, it is very essential to know the term what is called that molecularity. Molecularity is different, okay? Molarity is different. So what is that molecularity of the reaction? Usually in order to form the products during chemical reaction, the reactant molecules must collide. There will be one of the theory that is called collision theory it is. According to the collision theory, the reactant molecules must collide in order to bring about the chemical reaction. Okay? In order to bring about the chemical reaction, the reactant molecules must collide with each other. So then only the respective product will be formed in the chemical reactions. This is what very important only. In chemical reaction, reactants are converted into products. So how the products obtained in the chemical reaction, whenever the products are obtained, the reactant molecules must collide. Following, the reactant molecules means it may be atoms, it may be ions, it may be molecules. The ions or atoms or molecules that take part in a reaction, as represented by the balanced chemical equation, that is called what now? Molecularity. Following all of you, molecularity means it is the number we have to take. Is it not? Number means one molecule of the reactant, or two molecules of the reactant, or three molecules of the reactant. Following all of you, what is it? Molecularity means the total number. What is molecularity? The total number of the reacting molecules or atoms. The total number of molecules or atoms of reactants. The total number of molecules or atoms of the reactant that take part in a reaction as represented by the balanced chemical equation for the elementary step of the reaction, called what now? Molecularity. I am just giving you the definition, okay? What is it? Molecularity means total number of molecules or atoms, number of molecules or atoms of reactant, total number of molecules or atoms of reactant that take part in a chemical reaction, as represented by the balanced chemical equation, as represented by the balanced chemical equation, for an elementary reaction, is called a molecularity. Should know that clearly. Yes, what is molecularity? This is the definition of the molecularity. The total number of molecules or atoms of reactants that take part in a chemical reaction as represented by the balanced chemical equation for an elementary reaction or for an elementary step. This is called what? Molecularity. Following all of you, what is meant by the term molecularity? Molecularity is the total number 1 molecule or 2 molecule or 3 molecules, like that we can take the total number of molecules or it may be atoms of reactant that take part in a chemical reaction as represented by the balanced chemical equation for an elementary step. That is called what now? Molecularity of the reaction. Usually molecularity of the reaction is described by means of what now? That elementary step only. Always know the chemical reaction must be balanced. We have to write down the balanced chemical equation. In that balanced chemical equation for the elementary step, what is that number of the reactant molecules or it may be atoms taking part during the reaction, that is called what now? Molecularity. Following all of you, molecularity means total number of molecules or atoms of reactant that take part in a chemical reaction as represented by the balanced chemical equation for an elementary step or elementary reaction is called molecularity. You know what is meant by the term elementary step or elementary reaction? A single step reaction is nothing but what? Elementary step. A single step reaction is called elementary reaction only. The single step reaction is called an elementary reaction. In that elementary reaction, what is the total number of the reacting species? It may be atoms or molecules or it may be the ions taking part in a chemical reaction as represented by the balanced chemical equation for an elementary reaction. That is called molecularity. This is what very important. You should know carefully the definition of the molecularity. Usually one more question will be asking, is it not? What is it? Molecularity. So carefully and perfectly you should know the definition regarding molecularity of the reaction. Sometimes they ask the question, define molecularity. You just define like this. Number of reacting molecules or number of molecules of reactants, or it may be number of the atoms of the reactant that take part in chemical reaction as represented by the balanced chemical equation for an elementary reaction is called molecularity. Following. In the molecularity, there are different types. You should know that. Is it not? Types of the molecularity. Types of molecularity of the reaction. Types of molecularity of the reaction. Okay. I take first one. What is called? That is unimolecular reaction. Unimolecular reaction. Unimolecular reaction. You know that. What is the term? Unimolecular reaction, you know. I just give one of the example. Suppose NH4NO2 is one of the example. On heating, this compound undergoes decomposition to give what now? Nitrogen gas, and then water will be produced. So this is one of the example. Now you see, this is balanced chemical equation only. Ammonium nitrate, when heated, undergoes decomposition, means that will be split into what now? Two compounds. Like one is called nitrogen gas and one more is called what now? Water will be obtained during the process. This is one of the example for the unimolecular reaction, you know. What is meant by the term unimolecular reaction, you know? What is called unimolecular reaction? Molecularity means we know that number of the reacting molecules, number of atoms of the reactants that take part in a chemical reaction as represented by the balanced chemical equation for an elementary step. It is an elementary step only. It is a single step reaction only. This reaction is not taking place more than one step. It is taking place in only one step. The reactions which are taking place in only one step, they are called what now? Elementary step or elementary reactions only. In this elementary reaction, we should know the balanced chemical equation also at the same time. The reaction is now balanced only. In this balanced chemical equation, for this elementary reaction, how many number of the reacting particles will be involved, you know? Only one. This is what 1 mole of NH4NO2 is involved in the reaction. Only 1 mole is involved means its molecularity is 1. Its molecularity is 1. Molecularity is 1. What is molecularity is 1? Only one molecule of the reactant taking part in the chemical reaction as represented by the balanced chemical equation for an elementary step, that is called molecularity. Means one molecule of the reactant is involved, means then the reaction is called unimolecular reaction. What is it? Unimolecular reaction. The reaction is said to be unimolecular. The reaction is said to be unimolecular if only one reactant molecule that take part in the chemical reaction as represented by the balanced chemical equation is called what? Unimolecular reaction. Following all of you? What is called unimolecular reaction? The reaction is said to be unimolecular if only one reacting molecule that take part in the chemical reaction as represented by the balanced chemical equation is called unimolecular reaction. Have to understand the definition carefully. Following? The reaction is said to be unimolecular if only one reactant molecule, if only one reactant species taking part in the reaction as represented by the balanced chemical equation for that elementary step is called unimolecular reaction. And I give one more example for this one. One more example. You know that hydrogen peroxide, H2O2. Hydrogen peroxide on heating undergoes decomposition, gives what? H2O plus O2. And here you know this is 2 moles and here 2 moles of H2O and 1 mole of O2. Now the reaction in which only one molecule of the reactant taking part in the reaction as represented by the balanced chemical equation for a single step. This is one of the complex reaction. Is it not? What is meant by the term complex reaction? You know, the reaction which is explained in various steps is called one that is complex reaction only. Complex in nature. The reaction which is carried out, the reaction which is taking place in more than one step, or it is carried out in the several steps, then it is called what? Complex reaction. For this complex reaction, in which there will be more than one step will be there. For that single step reaction, we have to find the molecularity. Now there are 2 moles of the reactants, but molecularity is not 2 for this one. Molecularity is only 1. How it is only 1 means we should go through the mechanism of the reaction. Suppose I am telling you that, what is it? H2O2 undergoes decomposition to give H2O and nascent oxygen. You should know the pointer. Nascent oxygen. The freshly prepared oxygen atom is called nascent oxygen only. Now in the second step you see H2O2 that combines with what? The nascent oxygen obtained in the first step and gives rise to what? That H2O and then O2. Following? Now you see this one. If you want to write the overall equation, how to complete this one? Overall equation. How to write the overall equation means you just cancel this nascent oxygen and this nascent oxygen. Then what you are getting? 1 mole and 1 mole. 2 moles of H2O2, okay, gives rise to what? 2 moles of H2O, okay, gives rise to what? 1 mole of O2. This is what is called one of the complex reaction. It is explained in 2 steps. This is called step 1 and it is called what? That is step 2. Like this you can say that. Step 1 and step 2. Step 1 is what? That is a slow step only. And step 1 is what? That is a fast step only. Usually we consider what? Molecularity of the reaction based on that elementary step, based on that elementary reaction. In the elementary step, only one molecule of the reactant is involved. Hence, we consider what? That molecularity of the reaction is 1, is not 2. So, this is one of the example for what? That is molecularity of the reaction. This reaction is called what? Unimolecular reaction. Even this reaction you can also represent in this manner. 1 mole of H2O2 if you take 1 mole of H2O2 is obtained and half mole of O2 also obtained. Now this is one of the example for what? Unimolecular reaction. Unimolecular reaction means the reaction is said to be unimolecular if only one reactant molecule that take part in the reaction as represented by the balanced chemical equation. That is called what? Unimolecular reaction. Okay, now we will take one more second. Bimolecular reaction. Bimolecular reaction. Okay, What is this bimolecular reaction? In the same manner we can just define. Unimolecular means what now? Only one molecule of the reactant take place in the chemical reaction as represented by the balanced chemical equation. What is meant by that bimolecular reaction? The reaction is said to be bimolecular if two molecules of the reactant that take part in the chemical reaction as represented by the balanced chemical equation called what? Bimolecular reaction. I just give one of the example for this bimolecular reaction, okay? But that example for this, hydrogen gas, okay, plus iodine gas, okay, gives rise to what, two molecules of hydrogen iodide gas. Now this is one of the example for what, bimolecular reaction. Here 1 mole of hydrogen, here 1 mole of iodine and 2 moles of hydrogen iodide. This reaction is now completely balanced only, and the reaction is taking place what in only one step only. Therefore, it is an elementary reaction only. The reactions which are taking place in only one step, they are all called what? Elementary reactions. In this elementary reaction, what is that? Hydrogen plus iodine to give what? 2 moles of hydrogen iodide. Now we can take 1 mole of hydrogen and 1 mole of iodine are combined, are reacted. Is it not? Then giving 2 moles of hydrogen iodide. Now here 1 mole and here 1 mole, total of what? 2 moles or 2 molecules of the reactants taking part in a chemical reaction as represented by the balanced chemical equation called what? Bimolecular reaction. What is meant by the term bimolecular reaction? The reaction is said to be bimolecular if only two reactant molecules, if the two reactant molecules that take part in the chemical reaction as represented by the balanced chemical equation called what? Bimolecular reaction. For example, 1 mole of H2 plus 1 mole of I2 gives rise to 2 moles of hydrogen iodide. So we will consider only reactant side, 1 mole of hydrogen and 1 mole of iodine. These two are reactants only. These two molecules take part in the chemical reaction to form the product. Hence, the reaction is said to be bimolecular. What is bimolecular reaction? The reaction is said to be bimolecular if two molecules of the reactant that take part in balanced chemical equation as represented by, take part in the chemical reaction as represented by the balanced chemical equation. Okay? The bimolecular reaction means the reaction is said to be bimolecular if two molecules of the reactant that take part in a chemical reaction as represented by the balanced chemical equation. So this is one of the example for this one. Okay, third one you can take called what now? Termolecular reaction. Termolecular reaction. Termolecular reaction. Okay. What is this termolecular reaction? Termolecular reaction is 3 molecules of the reactant that take part in a chemical reaction as represented by the balanced chemical equation called a termolecular. Following all of you? I just give one of the example for this one. You know that FeCl3 combining with what? SnCl2 and forming the product FeCl2 and then SnCl4. We take here 2 moles of FeCl3, 1 mole of SnCl2, 2 mole of FeCl2 and 1 mole of SnCl4. Now just we'll see that equation. Ferric chloride combines with what? Stannous chloride, giving ferrous chloride and stannic chloride. Following all of you. So this is one of the example for what? Termolecular reaction. Termolecular means 3 molecules of reactant that take part in the chemical reaction as represented by the balanced chemical equation called what? Termolecular reaction. So this is also one of the type of the molecularity. What is it? Termolecular reaction. What is meant by the termolecular reaction? The reaction is said to be termolecular if the 3 molecules of the reactant that take part in a chemical reaction as represented by the balanced chemical equation called termolecular reaction. So these are the 3 types of the molecularity of the reaction we are studying in this chemical kinetics. Okay, and now you see one of the definition called what no? Elementary reaction. Elementary reaction. What is meant by the term elementary reaction, you know? The reaction which is taking place in only one step. The reactions which are carried out in only one step, they are all called what? Elementary reactions. The single step reaction is called what? An elementary reaction. You have to remember this carefully. Next one is complex reaction will be there. Complex reaction. What is meant by the term complex reaction? The reaction which is taking place in more than one step. The reaction which is carried out in more than one step, called what? That is a complex reaction. You know that decomposition of hydrogen peroxide is a complex reaction. Why that decomposition of hydrogen peroxide is the decomposition of the hydrogen peroxide is a complex reaction, you know. Decomposition of hydrogen peroxide is a complex reaction because this reaction is taking place in two steps. This reaction is taking place in two steps. Complex reaction means the reaction which is carried out in more than one step or taking place in the several steps called a complex reaction. So these are the terms now in the chemical kinetics. We should know that what is elementary reaction or elementary step and what is called a complex reaction. Following all of you. Okay. Now we will move towards the another one concept in this topic, what is called a order of reaction. This is very, very important also. In the chemical kinetics, based on the order of the reaction we are studying now, the different contents, even we solve the different numericals also. That is why we should know the term order of reaction. Order of a reaction. Okay. First of all, what is this order of the reaction? What is called that order of reaction? I am just giving you one of the example, what is called hydrogen gas combining with iodine gas gives rise to, you know, the product 2 moles of hydrogen iodide gas. Okay, in this reaction, we already know that how to write the rate expression for these kind of reactions, or how to write the rate law expression. Nothing but rate equation only. How to find the rate equation, you know? This is written according to the law of mass action. That is, R means rate only. Rate of reaction is equal to what? K into what? Molar concentration of the reactant, that is hydrogen, okay, to the power 1 into molar concentration of iodine to the power 1. This is the rate equation. Experimentally determined rate equation for this reaction, or the mathematical expression for the rate law, or the rate expression. Following, rate expression means we should know that according to the law of mass action, rate of reaction is directly proportional to the active masses of product of active masses of reactants at a given temperature. Following, according to the law of mass action, what is the statement? Rate of reaction is directly proportional to what? Product of active masses of reactants at a given constant temperature. Called what? Called what? That is law of mass action. According to the law of mass action, we write what? No, rate law. This is the mathematical expression for the rate law, or this is what is called now the experimentally determined rate equation. So how to determine the rate equation? By using the initial rate method we have studied. Following, how to determine the rate equation by means of initial rate method, we know that is experimentally determined. Here also experimentally determined. Okay, what I am telling is, you see the equation H2 plus I2 gives rise to 2 moles of HI. According to the law of mass action, we can write no rate equation. or a rate expression. Rate expression is given by this equation, R is equal to K into molar concentration of hydrogen to the power 1 only into molar concentration of iodine to the power 1 only. 1 means here 1 mole of hydrogen, hence we are right now power 1. Here also 1 mole of iodine, hence we are right now power 1 only. Okay, now we will go through that term, what is called order of reaction. What is meant by order of reaction, just I will give you the idea about the order of reaction. Sum of powers of concentration terms. Powers of concentration terms. Powers of concentration terms of reactants. Powers of concentration terms of reactants. Sum of the powers of the concentration terms of reactants found in the experimentally determined rate equation for the reaction. Rate equation for the reaction is called order. Listen all of you, what is meant by the term order of reaction? Sum of powers of concentration terms. Sum of the powers of the concentration terms of reactants found in the experimentally determined rate equation for the reaction, called what? Order of the reaction. Following all of you, what is called order of the reaction? Sum, SUM sum it is. Sum of the powers of concentration terms of reactants found in the experimentally determined rate equation for the reaction, called order of the reaction. For this reaction, can you tell me what is the order? Order with respect to hydrogen. Order with respect to hydrogen is how much? 1 only. And order with respect to iodine is also 1. What is the overall order of the reaction? How to get the overall order? You know that here order with respect to hydrogen is 1. Order with respect to iodine is also 1. Following. Order with respect to hydrogen is 1. With respect to iodine is 1. But I am asking that what is the order of reaction? What is the overall order of the reaction? It is a sum of what? Powers of concentration terms of the reactants found in the experimentally determined rate equation for the reaction. This is called order. Now you tell me what is the overall order of the reaction means. Order with respect to hydrogen is 1 and order with respect to iodine is also 1. This is equal to 2. The reaction is said to be what? Second order. The reaction is said to be what? Second order. Following all of you. What is order? It is a sum of the powers. Here 1 plus 1, that is equal to 2. The reaction is said to be second order kinetics. Following all of you. Okay. Now here you see the definition of the order of reaction is very, very important. Sum of the powers of the concentration terms of reactants found in the experimentally determined rate equation for the reaction. That is called order of the reaction. What is the order of the reaction? That is hydrogen plus iodine gives rise to 2 moles of hydrogen iodide. The order with respect to the hydrogen is 1. The order with respect to the iodine is 1. The overall order of reaction is 1 plus 1, that is equal to 2. The reaction is said to be second order or second order kinetics. I give one more example for this one. We know that already this reaction NH4NO2 gives rise to what? Nitrogen gas, and then water, 2 moles. According to the law of mass action, can you write the rate equation? R is equal to K into molar concentration of NH4NO2 it is. K into molar concentration of NH4NO2 to the power how much, you know? To the power how much? This equation is balanced chemical equation only. 1 mole of NH4NO2 gives 1 mole of nitrogen, 2 moles of water only. Okay, no? So now R is equal to K into, according to law of mass action, this is the rate equation. Experimentally determined rate equation for the reaction it is to the power 1. Then what is the order of the reaction, you know? Only one. It is said to be what, no? First order. First order. Following all of you. First order reaction. So in this way, we should know that what is the order of the reaction, how it is obtained. Usually, order of reaction is obtained experimentally. Order of reaction is always obtained experimentally. It is experimentally determined from the rate equation. Order of reaction is always experimentally determined. It is not obtained from the balanced chemical equation. Molecularity is obtained from the balanced chemical equation. What is the total number of the reactant molecules? What is the total number of the reactant molecules taking part in the reaction as represented by the balanced chemical equation for a single step reaction? That is molecularity. Molecularity is obtained by means of balanced chemical equation. But order is always obtained by means of what? Experimentally determined rate equation for the reaction. It is always obtained from the rate equation it is. That is experimentally determined rate equation. It is not theoretical. Order of reaction is not theoretical one. There will be some questions will arise in our mind. Is it not? How it is? This is the reaction. What sir you have written directly that rate equation? This reaction is a single step reaction only. For single step reaction, order of reaction is obtained from the balanced chemical equation only for single step reaction. In the single step reaction, only 2 reactant molecules involved means no, the overall order of reaction will be 2 only. Order with respect to hydrogen is 1 and iodine is 1, overall order is 2 only. It is also single step reaction. NH4NO2 gives rise to N2 plus 2H2O. The order with respect to NH4NO2 is 1 and overall order of reaction is also 1. So there are some reactions which may taking place either in one step or in multi steps. For single step reaction, order of reaction is obtained from the balanced chemical equation. It is theoretically as well as experimentally. The order is the same only. Theoretically if you take no 1 plus 1 2 you are getting second order you are getting. Experimentally if you determine no you are getting the second order only. Because those reactions are taking place in the single step reaction in which no what is that balanced chemical equation. Usually order of reactions are not obtained from the balanced chemical equation. Order of reaction is always obtained by experimentally determined rate equation only. Obtained from the experimentally determined rate equation, not from the balanced chemical equation. But what I am telling here is, if the order of reaction is experimentally same and theoretically same is, directly you can write like this, rate equation for the reaction. This is rate equation and this is rate equation. It is always obtained, order of reaction obtained from what? Experimentally determined rate equation only. It is not obtained directly, it is not obtained theoretically, it is not obtained from the balanced chemical equation. Always order of reaction is obtained or found in the experimentally determined rate equation. It is not directly taken from the balanced chemical equation. But for the single step reaction, order of reaction is obtained from the balanced chemical equation. For single step reaction, for elementary step reaction. Are you following this point? And there are some points. Order of reaction is the sum of the powers of concentration terms of reactants found in the experimentally determined rate equation for the reaction, that is called order of the reaction. So now here in the case of the order of the reaction, I just give some example like this. A plus B gives rise to what C plus D. This is one of the reaction, C plus D. Here small a and here small b and here small c and small d. Okay. What is the rate equation for the reaction, you know? Rate equation for the reaction R is equal to K into molar concentration of A to the power m I take and molar concentration of B to the power n I take. What is that m and n? M and n are the order with respect to A and B. M is the order with respect to A and n is the order with respect to B. What is the overall order of the reaction, you know? Overall order of reaction is equal to what? M plus n. M plus n may be equal to A and B, A plus B, or may not be equal to A plus B. You should remember the point. M and n may or may not be equal to A and B. It is, don't think that it is same as A and B, same as that of what M and n. M plus n may or may not be equal to A plus B. That is what order of reaction is obtained experimentally, not from the balanced chemical equation or not from the theoretical equation. It is always found in the experimentally determined rate equation. Okay, I give one more example regarding the order of the reaction. I give one more example regarding order of reaction. You know that H2O2 on decomposition gives rise to H2O plus O2. Can you balance the equation? Okay. On balancing this, we get what? No, that 2 moles of H2O gives 2 moles of H2O and 1 mole of O2 obtained. Can you tell me now? This is one of the complex reaction. It is explained in 2 steps. The reaction is explained in 2 steps. What is the first step of the reaction? First, 1 mole of H2O2 undergoing decomposition to give H2O and then nascent oxygen. H2O and nascent oxygen. In the second step, what happens, you know? Again, H2O2 combined with that nascent oxygen obtained in the above step. So, giving what? That H2O and then O2. Now, this is what? No? First step of the reaction, and it is the second step of the reaction. Now, first step of the reaction is a slow step only, and second step of the reaction is a fast step only. Can you tell me why it is a slow step? You see this one, H2O2 is a neutral molecule and it is a stable compound. In order to undergo decomposition, it requires energy. Therefore, it takes some time because the molecule H2O2 is stable. The molecule H2O2 is stable. The stable molecule should form product means no, it takes some time. Therefore, this first step of the reaction mechanism is now called slow step only. Now you come across the second one. How do you say this second reaction is fast? It is second reaction is fast because this is nascent oxygen. Nascent oxygen means already you know that the freshly prepared oxygen atom is called what? Nascent oxygen only. Hydrogen peroxide molecule is a stable molecule, combines with what? No, reactive species, that is nascent oxygen O. Immediately it gives the product like H2O and then O2. Therefore, this reaction is fast because in the second step the reacting molecules will be present already. In the first step, no, this is not immediate reactive. It takes some time. It is a stable molecule. It is not stable. Because of unstable nature, it possesses very high energy. Therefore, it reacts immediately with what? H2O2 and forming the products H2 and O2. For this one, we can write now overall equation also. This nascent oxygen and this nascent oxygen will get cancelled. And what do you get here? H2O2. How many moles? 2 moles only. And giving what? 2 moles of H2O. Okay. And then what? 1 mole of oxygen gas. This is what the reaction. Here it is obtained. This reaction is explained in 2 steps. One step is fast and one step is slow step. So now here, in case of the complex reaction, order of reaction is obtained by means of the slowest step of the reaction. Slowest step of the reaction means the rate of this reaction depends upon the slowest step. In the case of the complex reactions, the reactions are taking place in what? No, more than one step. In which no, one step will be slow step, and remaining will be fast steps it is. Out of these, the slowest step of the reaction mechanism is called what, a rate determining step, is called a rate determining step. Is it not? This is what very important term. What is a rate determining step? Rate of the reaction depends upon this step only. Rate of the reaction depends upon the slowest step only. Hence, the slowest step of the reaction mechanism called what? Rate determining step. Rate of reaction is not depend upon second step. It depends upon the first step. It is quite fast only. It is slow only. Hence, the rate is depend upon the slowest step of the reaction mechanism. Means, then the slowest step of the reaction mechanism is called a rate determining step. Now, what is our question? In case of the complex reaction, order of reaction is always obtained from what? A rate determining step. Order of reaction is always obtained from the, or found in the rate determining step. Which one is rate determining step? First step. According to the law of mass action, what is the rate equation for that? R is equal to K into molar concentration of hydrogen peroxide to the power 1. Okay. Only one molecule of the reactant that is taking part in the reaction, to the power 1 only. Then what is the overall order of the reaction? Order of reaction is only 1. And it is said to be what? First order. Said to be what? First order. Following all of you. So now this is what very important. Now the reaction seems to be second order. If you see the reaction, it seems to be what? Second order, but actually it is first order. How it is? It is a complex reaction. It is taking place in 2 steps. In which is slowest step? This one. In the slowest step, what is the order? That is 1. Therefore, order of reaction is found in the experimentally determined rate equation for the reaction, not from the balanced chemical equation. It seems to be second order, but the order of reaction is first, that is first order. Order of reaction is 1, means that is first order only. So in this way, the rate determining step. What is the rate determining step? What is that complex reaction? And what is called that elementary reactions? These are all very, 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 very important. Okay. We should know that characteristics of the order of reaction. Order of reaction with respect to the given reactant is the order of reaction with respect to the given reactant is the power to which the concentration term raised in the experimentally determined rate equation. Following all of you. Here you see that in this equation, order of reaction with respect to the hydrogen peroxide is only 1 only. Overall order of reaction is also 1. Order of reaction with respect to the given reactant is the power to which the concentration term is raised, or to which the concentration of the reactant is raised in the experimentally determined rate equation. In case of what no, that is complex reactions, order of reaction is obtained from what no, that is slowest step of the reaction mechanism. Order of reaction is always obtained from the experimentally determined rate equation, but in case of the complex reaction, order of reaction is depending upon the slowest step. Slowest step is the rate determining step. These points we should know about the order. And one more point you should know that order of reaction may be 1, or it may be 2, it may be 3, or it may be 0, or it may be a fraction, like this it will be. So in general we can say that order of reaction may be a whole number, it may be 0, or it may be a fraction. But molecularity never be 0, it never be fraction. Molecularity is always a whole number. You remember the point. Because when the reaction is taking place means only one reactant molecule must involve, or 2 reactant molecules must be involved, or 3 molecules of reactant must be involved. That is what unimolecular reaction, bimolecular reaction, termolecular reaction. Unimolecular reaction means the molecularity is 1. Bimolecular reaction means the molecularity is 2. Termolecular means the molecularity is 3. Molecularity is 0 means no molecular. Therefore, molecularity never be 0. Molecularity never be 0. Always it is whole number. But order of reaction maybe whole number, maybe fraction, maybe 0. So these are the points, some important points about the order of reaction. We must know that. These are all very, very important only what I am telling. Following all of you. Okay.